Yeah, no problem.
Yeah, started.
Okay. Good morning. Okay, I'll start.
Yeah.
Good morning, and again, welcome to CNS Lab Meet event. For today's schedule, we kick off the event with a talk by Nilima Gupte. Dr. Nilima Gupte is a physics in IIT. She is also the main PI for IITM Center of Excellence for Complex Systems and Dynamics. Without further ado, over to Dr. Nilima ma'am for the talk. You can start.
So you
can share my screen, Sundari.
Yes.
I share the PDF.
Yes. Yeah, 1 second, ma'am. I'm sharing it now. Yeah, is it okay?
Yeah.
Okay. So good morning, everybody. I'm Nilima Gupte. Sundari has just introduced me, and I'm happy to share I'm very happy to join Srinivas in welcoming you to this workshop. And this workshop this year, Srinivas actually holds this workshop every year. So this is a new feature that this year it's being held under the Center of Eminence for Complex Systems and Dynamics. So I just want to spend a few minutes explaining to you what this Complex Systems and Dynamics Center at IIT Madras is. Okay. So one important thing about the Center for Complex, one important thing I want to tell you about the center is that we have been, I'll just tell you when to change the slides, is that informally, this group has been interacting for more than 3 years. In fact, Srinivas and I have been interacting for something like 20 years. But last year, when IIT became Institute of Eminence, these centers, the institute wanted people to come together and form these centers. And so, in fact, one thing which we did was we had put in a formal proposal for this interdisciplinary center a while ago, and that actually the proposal came into being last year. Okay. So let me just explain what is the idea to this center and what is the idea. This group involves people from several departments, as you will see. Okay. So what is the idea? So this is an interdisciplinary group, and it's a fairly large interdisciplinary group. And I would like to share to you what do we mean by what is the idea behind this center. So next slide, please, Sundari. Yeah. So you know that you people, most of you are interested in, you have joined this workshop because you're interested in computational neuroscience. And therefore you are fully aware that many systems in nature and the lab, they exhibit very complex dynamical behavior. This ranges from synchronization and self-organized behavior to chaotic behavior and turbulence. Next slide. So such behavior can be seen across a huge range of complex systems. For example, you see synchronizations in simple systems like oscillators, which are often used in neuroscience, as well as flashing of forms of fireflies. You see what are called coherent structures with length scales which range from fairly small ones like voles and tendrils in the laboratory flows to the great red spot of Jupiter, which extends over thousands of kilometers in pattern formation, which can be seen in chemical reactions, sand dunes, snake skins, animal coats. That's a fairly diverse set of systems. Next one. Next slide. There's also the phenomenon of self-organization. So you see self-organization in all kinds of behavior, from flower petals to the flocking of schools of fish. Okay. So an important point which you will have noticed from these examples is that all these systems, which are seemingly very different, actually show a commonality of behavior. And this commonality of behavior seen across a diversity of systems has resulted in the search of basic organizing principles that lead to this universal behavior. Next one, please. Can you change the slide?
Yes, ma'am, I did.
So now how do you, yeah, I got it. So now it's a case of how do you identify these organizing principles? Okay. So one of the ways in which these organizing, so I come to the topic of complex networks, which is one of the ways in which these organizing principles can be exposed by using the paradigm of complex networks. What is a network? Many of you are probably already familiar that these consists of various nodes connected via links, which could be, so the nodes are could be individually evolving units, and the dynamical interactions and the links could actually be dynamical interactions between individually evolving units. Okay? And you'll be aware that in computational neuroscience, you often use these networks, complex or otherwise. Next one. Yeah. So examples of such systems include chemical reactions, metabolic networks, food webs, internet and power grids. Very important this year, contact networks of epidemic spread, social networks like Facebook, or even better, the collaboration networks of scientists. And like networks of epidemic spread are very important in the practical context this year, collaboration networks of scientists is exactly what our COE is about. Go on. Next one. So some of the methods which we use are methods of algebraic topology, methods of graph theory, methods of statistical mechanics. So these are the methods which are used. And what do we use them for? We use them to understand the collective behavior of interacting units, okay? And the relation between structure and function, which is crucial for real life applications, including neuroscience. Next. Yeah, next slide. There is, so the kind of thing which I'm talking about has been addressed for many years. These kind of studies have been done for many years, but in recent years there has been a new element to these, and that is the element of data driven analysis. Okay, and the new element is that there is the availability of data sets on large scales which were unthinkable even a few years ago. Okay. And the identification, the organization, and the analysis of such data, they need to draw on the methods of data mining, artificial intelligence, neural nets, deep learning algorithms, all of which enter in computational neuroscience in order to construct realistic models. Okay. Next, please. So this can be very useful. You can construct realistic models using methods of probabilistic and causal analysis. And this can be very useful both from the understanding of systems as well as the prediction of systems. If you could predict catastrophic events like earthquakes, power grids, stock market collapses. We are working on climate networks where we are looking at predictions of events like the El Nino and La Nina. So all these can be useful from the practical point of view. Next one. Yeah, next slide. So what is the research potential in this area? No, just go back one slide back. Yeah. So research in this area, this has the potential. Research in this area is very important, and it has the potential both to understand fundamental questions as well as to address global questions like climate change, pandemics, mass migration, and ecological disorders. And from the engineering point of view, it also includes the possibility of harnessing technology towards growth and the improvement of life and the environment. So this is a very rich subject with a lot of potential. And many of us thought that since we have expertise in different aspects of these things, we could come together and see what we could do together. So in addition to the research projects which we have on all these areas, which I have just talked about, which many of these areas we have research projects on, which I will not have the time to go into detail in. But there's a very important thing which I want to share with you. That's in the next slide. Yeah. We have an important teaching program here, that is the interdisciplinary dual degree in complex systems and dynamics. It is open to all dual degree BTech plus MTech programs of IIT Madras. And there are common courses in the first 2 years, and in the third year, in the 6th semester, we actually start the dedicated courses for this, which include all of the techniques which we have been, many of the techniques which we have been talking about. Next one. Yeah. So this course can enable students to understand and contribute both to the fundamental understanding of universal features, as well as equip them to a level which can translate into delivering technology, which is useful in industrial and societal contexts. So therefore, the interest in this IEEE, people can be interested in this IEEE program from two distinct points of view, and also, of course, from the point of view of both, which was our point of view when we set it up. Okay, next. So a little bit about the PCOE. So as I said, it has both research programs and teaching programs. It has 8 members from IIT Madras, drawn from a variety of departments: physics, biotechnology Srinivas, aeronautical, applied mechanics, chemical engineering. It has a number of international members from Europe, North America, and South America. This is a very strong component of our PCOE. We have numerous collaborators from India and abroad, including from other IITs. Next slide. Yeah. The next slide, please. As I would encourage people, there's a lot of students over here, and I would encourage people to see if they are interested in different aspects of our regular teaching programs as well as our research programs. There are also supposed to be young faculty over here, researchers in the field, and I would like to tell you that positions are available with us. The positions which are available with us are young international faculty under the PCOE program, okay? Postdoctoral fellows and students under IITM Institute postdoctoral fellowship schemes, as well as the regular PhD, MTech, and MS programs. And there's also room for some project staff. Okay. So more or less, I've finished telling you all the essential facts that I need to tell you about the center. We have a website, we have a Facebook page. Please have a look, where you will find many more details which I have not been able to tell you. And so I hope some of you will be interested in joining some of our programs from different points of view. You have already joined our first official program, namely this workshop. And please enjoy the workshop, and I hope you will all enjoy the talks. So I'll stop here. Thank you, Srinivas, and thank you, Sundari.
Thanks a lot, Nilima. Thank you.
Yeah.